All right, now we're going to be talking about thunderstorms. Uh, I wanted to really wait and give a good one when there's a lot of activity going on, and there's a lot of activity going on today out in the Midwest, basically starting all the way down in Alabama, Mississippi, uh, and then on up through into West Virginia. So this is a mesoscale discussion. What Every thunderstorm is kind of on a smaller scale. Yes, they develop along fronts or they develop near low pressure systems or sea breeze fronts. But the actual thunderstorm, just look at the radar here. You see a little cell here, a little more intense than one over here, another one back in here. They're scattered. They're not a solid area. And even if they were, they don't cover a large amount of distance. So these are all small scale. I showed you earlier how huge of an area extratropical cyclones take in. Well, today we're going to look at the smaller scale, convection. So what is going on here? Well, this is where a tornado watch is out right now. This is part of Tennessee, basically from Memphis almost into Nashville right now. So why is there a tornado watch out here? Well, let's take a look at some conditions that might be causing this. Uh, so let's start off in the upper levels here a little bit. We have a surface front. You saw it on that picture right there before. Now, if you look aloft, you see a big jet stream stretching basically from New Mexico, even Mexico, all the way up through Oklahoma, Missouri, all the way into New York. And along that jet, we can see a pretty good jet stream coming into here, over 100 knots of wind are blowing in this area, and with really good divergence. The yellow is divergence. So there's really good divergence over Arkansas, then over Tennessee area here. And this is a jet stream that's moving. So this area of divergence will be moving over into this area later. So this was as of 8 o'clock this morning. So some of this is already progressing into this area. So now we have divergence aloft, and I wanted to show you a morning sounding from Jackson, Mississippi. Uh, what you see here is temperatures are plotted into red, and the green is dew points. Notice how down low, dew points and temperature are very close. This was at 8 a.m. this morning, so you've got to think, oh, we're now at 4 o'clock in the afternoon. How has this changed? Well, temperature surely warmed, right? The dew points actually come up as well a little bit. So you're shifting the lower part of the sounding over into this area. And what happens is this area actually, the line here is the moist adiabatic, or in other words, if we put the air parcel up all moist, completely saturated, this was the temperature it would follow. Notice the difference between this air parcel and the actual surrounding. We got a pretty big difference here. That's the area of instability. And it's going all the way up here, close to about 13, 14 kilometers up. And maybe even go higher than that if you have a really accelerating parcel. Also, notice here, dry. Well, if I'm throwing a moist air into that dryness, what's going to happen? That sound is going to move, cool off. So you're even getting more instability in here. So you wind up, if you look at just this sounding, what we've seen with divergence aloft, we're saying, oh, if we can get these air parcels to really start moving upwards this afternoon, they're going to really take off and go very quickly. That is what happened in here. That is why we're seeing this area tornado watch right now. You'll notice here, there's a little stationary front, but here there's a little bit of a low pressure. You can actually see it in the wind fields. We have counterclockwise winds right here at the surface. So you wind up with that influence. You're getting good moisture coming up east of it. You're getting, with that kind of convergence into the low levels here, you're winding up with a lot of potential for thunderstorms in this area this afternoon. Now, that's why there's a tornado watch out. And now we're going to look a little bit further east of that. And gee, there's another one out over the eastern part of Kentucky and almost into West Virginia. Same kind of things are going on here. Notice the cloud cover here. Really not a lot of clouds down to the south. There's some bubbly cumulus clouds, a little thicker up to the north. Temperatures are really heating up in this area. Winds are pulling them up. And also notice there's a flash flood threat out over this whole area as well. Why is that? Well, think about it. Winds have been going from the southwest to northeast and aren't moving a whole lot. This pattern is blocked. We've talked about blocking weather patterns before. This is doing all of that. So we're picking up on, we have really good conditions for thunderstorms, very great instability. We have good divergence aloft. We have a front close by that's helping to push the lift up. We have convergence at the surface. So now we're going to get into what type of thunderstorms. One of the main things that controls the type of thunderstorm is wind shear. The greater the wind shear, the better chance of tornadoes. So if I went back and we looked at this sounding here this morning, this is called a hodograph. We're not really discussing a whole lot of that in this course. All it is, it says right here, winds are 0. They're not moving, perfectly calm. This is the direction the winds are coming towards. So right here, they're coming out of the southeast at 10 knots. They're coming out of the south at this elevation at almost 40 knots. Then we're coming around over here, again, about 30 to 40 knots. Notice the shape. It's a curve. When we look at hodographs, we want to see a curved hodograph, usually in this way. We want kind of southeast winds blowing into the low pressure, and we want winds aloft to be more out of the south or even southwest, which we see up here. Very strong winds up in here, as a matter of fact, 30, 40 knots or more. So even some 50 knots right in here. 35 to 40 knots means you have enough wind shear probably for severe weather and multicellular storms. So we're getting multicellular, and we can even look at the sounding, and we can see here right at 700 millibars, we have 50 knots. So you see southeast, and the winds are turning with height. We've got great wind shear in here. So this is being projected up over what you're seeing in Tennessee. All this is coming together to give us the potential for severe weather across parts of Tennessee, on up into Kentucky. So now you can see how the meteorologist goes about and what you've learned this past week on how you should go about looking at severe weather. Now I want to take it a little bit further. There's a Storm Prediction Center has what they call hourly mesoscale analysis. And we're going to look at a couple different fields that aren't talked about. We can talk about convergence all we want. We talk about convergence of winds. Well, guess what? You can look at wind converging, and you can look at moisture converging. Moisture convergence, if you get a strong moisture convergence, you're looking at a lot of thunderstorm development. Notice, right from here in southern part of Arkansas to northern Mississippi, all the way across Tennessee and on up into Kentucky, that exact area where we had the watches out. We'll probably have more later. Really very strong moisture convergence in that area. So now this is real time. So this is what's happening right at this moment. So we would expect these thunderstorms to continue to enhance and move up across that area. And I want to look at another part here. So let's look at thermodynamics. And this is instability, or CAPE. CAPE is convective available potential energy. So it's basically amount of energy that's available to these storms if they start lifting up. Well, if I look at this, here's 2,000 joules per kilogram, 2,500, 3,000, 3,500, 4,000. I'll tell you this, I see CAPE above 1,500 when I have good lifting mechanisms. I'm very concerned there's going to be severe weather. And guess what? We have CAPE above 4,000 in this area, so there's probably going to be some very significant thunderstorm activity developing in this area, possibly even significant tornado development with time as well this evening. So that area is one area to be looked at. Another aspect that I can look at in the mesoscale here is wind shear. So I want to know the wind shear from the surface to 6 kilometers. That's been correlated very effectively with supercell thunderstorms. So we got wind shear above 40 to 50 knots, and we do. You can even see some north areas. We have 80 knots, but we're down here. We're looking in this area. Here's 50, here's 60, here's 70 knots of wind shear. A very, very strong wind shear in this area as well, moving to the northeast. So all of that indicating the potential continued development of these thunderstorms. So finally, let's just bring it down to the thunderstorms. Let's look at some thunderstorms a minute. I wanted to look kind of at the velocity data. I found a couple things that I found interesting. I want you to notice green is toward the radar winds. Red is away. So we're going to look at right in this area. And notice all the winds blowing outward to here and then blowing back in the other direction. This area is very strong convergence. You can see it on the satellite right here. And I want you to look here, right in this little point right here. I have winds going this direction one way and this direction the other. I actually have a circulation already beginning to develop here. This has the potential. We've talked about mesoscale circulations. So we're going to see, we can actually see one right in here, right now. If I were to look at products and we look at reflectivity, wow, look at how that thing is a hook already is developing into this area here. Very, very strong thunderstorms in here with the intensities you can see, all into reds, almost into whites in this area. So this area probably in here may have a tornado warning very soon. We can see some other interesting things back in this area. We can also see hydrometeor classification. We talked about dual pole radar. It's where we begin to see, oh, what's a different type of precipitation? And interestingly, right along this area, you can see it kind of green back in here, which shows pretty heavy rainfall and all. Well, right in here, we're actually seeing the beginnings of hail showing up in this area. So we actually have hail aloft combined with wind shear and all. So you can see these are very intense thunderstorms that are developing and are probably going to get more intense with time. And finally, one last thing we can look at off of this product is precipitation. So let's take a look at just how heavy the rainfall is. Notice some very heavy rain up in here the last hour, over an inch, going on an inch and a quarter, out in here, an inch and a half in 1 hour. So we think about that, all that's leading to very heavy rainfall and the potential for flooding. So what we've done here is analyzed, okay, we can expect the thunderstorms to develop along this frontal boundary. We know there's instability, so we got the thunderstorms. We know there's wind shear, so we have a multicellular thunderstorm like squall lines, maybe even supercellular. We've seen also now looking at some SPC stuff that we're looking at very high, right now, real-time cave, real-time wind shear. And we finally can even look at the radar, and we can actually see convergence on the radar, even some rotation, development of these thunderstorms. And if I had showed you lightning, one of the things we would look for is a lightning peak. If the lightning is all of going along at one level and all of a sudden jumps to a much higher level, that's an area that thunderstorms may be significantly developing, and we can expect the potential either for tornadoes, large hail, damaging winds. So I hope you got a little bit out of this and you can see how to apply what you've been learning this whole week. So let me know if you have any questions.